Hello, my name is Keshwani. It's Keshwani, Keshwani. We are here because we want to learn algebra. Today is our lesson number 94. Lesson number 94. We are in the process of learning, here's the course schedule, we are in the process of learning 86 through 100. We are in the process of learning how to solve linear equations. Let's see what we have for today. (2x plus 4 over 3 plus x minus 2 over 5), we are told that it equals 7. Well, let's get going then. First thing first, we have a denominator of 3 over here and we got a denominator of 5 over there. That's not going to do it. We need a common denominator. A common denominator for 3 and 5 is going to be 15. How do we convert this 3 into a 15? Well, multiply the top and the bottom by 5. So now it has a denominator of 15. This has a denominator of 5. How do we convert it into 15? Well, multiply the top and the bottom by 3. In other words, give this guy what he needs, which is a 3, and give this guy what he needs, which is a 5. And then let's multiply this by top and bottom by 15. Now the entire equation has a denominator of 15. Since the entire equation has a denominator of 15, every single term on both sides of the equation have the same denominator, well, we can ignore it. For example, 30 divided by 15 plus 45 divided by 15 equals 75 divided by 15. 75 divided by 15 is 5. 30 divided by 15 is 2. 45 divided by 15 is 3. 2 plus 3 is 5. This is a valid equation. Nobody's going to argue with this. This is a valid equation. But because 15 appears as a denominator in every single term on both sides of the equation, in other words, throughout the entire equation, 15 appears as the common denominator, it plays no role. It is there just to annoy you. You can ignore it. You can ignore it and will still be a valid equation. Voila. 30 plus 45 does equal 75. So that's what we're going to do here. Now that we have the common denominator of 15 throughout the whole equation, we're just going to ignore it. So what we have here is 5 times 2x plus 4 plus 3 times x minus 2. We are told that equals 7 times 15. Don't waste your time trying to multiply what 7 times 15 is. We'll do it at the end if we have to. If we don't have to, we won't do it. Now we have to open the parentheses. 5 times 2x is 10x. 5 times positive 4 is positive 20. Then we have positive 3 times x is positive 3x. And then we have positive 3 times a negative 2. A positive 3 times a negative 2 is negative 6. And we are told that equals to 7 times 15. Let's combine our like terms together. We have a 10x here, we have a 3x here. 10 plus 3 is 13. 13x. And then we got a positive 20 and a negative 6. A positive 20 and a negative 6 makes positive 14. Looks like we'll have to multiply 7 times 15 because whatever that quantity is, we need to subtract 14 from it in the next step. Let's figure it out. 7 times 15. 7 times 5 is 35. That's a 5. Carry 3. And 7 times 1 is 7 plus a 3 is 105. And if you do not know what I just did here, I'm going to do it slowly in a little bit slower way. But let me explain one more time what I did here and then I'll do it out for you actually. Watch here. 7 times 5 is 35. So the 5 comes over here. Carry 3. And then 7 times 1 is 7 plus the 3 that we had gives us 10. Let's do it here. 15 times 7. 7 times 5 is 35. That's a 5. carry 3. 7 times 1 is 7, plus the 3 gives us the 10. Now we need to subtract 14 from both sides to get rid of this 14. Positive 14 and negative 14 is going to cancel out. Of course, that was the whole point. This 13x is going to come down. 105 minus 14. 105 minus 14. Well, 105 minus 5 would have been 100. Therefore, 105 minus 15 would have been 90. But we don't have 15, we have 14, so it must be 91. That's it. Is it 91? I'm beginning to doubt myself. 5 minus 4 is 1. Yes, of course. Well, I don't know why I was making such a big fuss about it. It's very simple actually. Just do it out. 5 minus 4 is 1. 10 minus 1 is 9. Oh, Jesus. Okay, so now the question is, how many 13 does 91 have? I don't know, and don't pick up the calculator. Leave the calculator alone. As I said, give the bloody thing a break, okay? Let's do it out. We know that, where should we do it? Let's do it here. I know that 13 times 5 is 65. That I know. 13 times 5 is 65. I knew that by heart. Let's add one more 13 to it. So 78 represents 613. We're not there yet. We need 91. Let's add one more 13. 8 plus 3 is 11. There you go. We're getting the same in the 91. Therefore 91 apparently is 7 13s. So if you divide both sides by 13, 13 will cancel out and x equals 7. That's our answer. X equals 7. The last thing that is left to do for us before we call it a day and before we get too merry and so forth, too happy, is to plug in this value of x in the original equation that is given to us and see if it holds. In other words, see if x equals to 7 satisfies the equation. Let's do it. Let's get rid of this extra stuff that we had put in the beginning. We don't need any of that. This quantity plus that quantity better add up to 7. That's what we are saying. So let's do it. X equals 7. 2 times 7 is 14. 14 plus 4 is 18. 18 plus 3 is 6. Well, if that's 6 and this has to be 7, this better be 1. X equals 7. 7 minus 2 is 5. And 5 divided by 5, what do you know, is 1. There we go. Equals 7. One more time, if you like, slowly. X equals 7. Let's put it in here. X equals 7. Put it in here. 2 times 7 is 14. 14 plus 4 is 18. 18, the top quantity is 18. 18 divided by 3 is 6. Since we want the whole thing to be 7, this better be 1. X equals 7. 7 minus 2 is 5. 5 over 5 is 1 that we need. Voila, that's it. It works. It works. Everything fits in. Everything is nice. I will see you tomorrow on day number 95. 6 more days to go before we start our word problems. At the end of the 6th day, as the end of day number 100, at the end of day number 100, I will consider having done half the course of the first semester of algebra. This is only the basic, a very elementary algebra is what we're doing here. Algebra involves a lot of fancy things in it. There's a quadratic equation, there is a simultaneous equation, there's a lot of things. There is a factorization, there is a lot to learn, but all of that is what I consider second semester. The first semester is made up of this 100 days that we just did, that we're in the process of finishing, plus learning how to solve simple word problems. And I'm going to do 100 examples for you. I think that should be more than enough. That should suffice. I'll see you tomorrow, okay?